Okay, question 2. It's a long one. There's a lot of this, so I'm just going to take it piece by piece. The graph of this function intersects at 0c. Find the value of c. That's fairly simple. We just plug in x equals 0. So we're going to go 1/2. Oh, that's not the right color. Let me get 1/2. 0 minus 2, 0 plus 8, and we get 1/2 of -2 times 8. That would be, this would be -16, and half of that would be -8. So c is equal to -8. Cool. Okay. The vertex is at -3, -12.5. Write down the equation for the axis of symmetry on your graph. So think about what that might mean. Let's get ourselves a little bit of a sketch of what's happening here. Is that we know that at -8, the function is crossing, and at -3, -12.5, about there, -12.5, we've got the vertex. That means the axis of symmetry is like right through there, so it's just going to be x is equal to -3. That's all they're looking for. And if you get stuck, I always just like sketch that picture in your brain or something. Cool. Let me know if you have questions. 2c, the equation f of x is equal to 12 has two solutions. The first is at x equals -10. So this is saying when y is 12. So if we extended our graph up here a little bit and we said, okay, let's make y 12 here. And it's saying that there's two solutions. Well, obviously there's two solutions because that line, y equals 12, would cross our parabola here and would cross our parabola here. The first one is x equals -10. So if we went back here, it's claiming that this point right here, -10, -10, 12 is a solution, and it wants us to figure out the other one using symmetry, which is why this picture is super helpful. Well, this distance right here, let me make a color you can see. This distance right here is 7, which means that by symmetry, over here, whatever value that is, that distance also has to be 7, and I have clearly done a terrible job of drawing, because if this is -3, then this, whatever is left over here, has to be 4. But it's basically just the argument of 7 and 7 so that it is symmetric, because parabolas are nice and symmetric. So that's what they're asking for with 2c. That once the x-intercepts of the graph, so the x-intercepts is where is it going to cross the x-axis. And since we got this in factored form, that's how we can get those x-intercepts really nicely, because you know that the solutions here would just be 2 and -8. So that's saying that this value right here, again, I did a bad job of drawing this, that would be -8, and that value right there would be 2. So the x-intercepts are, and when it says intercepts, you probably want to use the full coordinate, so like -8, 0, and 2, 0. On graph paper, sorry, wrong thing, draw a graph of this function for -10 to 4 and -14 to 14. So let's actually do a nice job with that. Let me get some graph paper. Okay, I stole this, just a screenshot from Desmos. I turned the axes off, which you guys can do. There's a little clicker button next to that. I don't care, by the by, if you don't have graph paper and you don't have like a tablet to write on. Just sketch in your notebook. That's totally fine. Basically, they're asking us to draw a better picture than this really crummy picture I drew over there. And they want, again, so the axis, like x is going to be -10 to 4. So we need 14 here. And I've got like, that's 10, that's 15. So let's draw that right there. And y is going to be -14 to 14. Which I don't have enough room for, so let me fix that. Okay, something like that. Then let's get our important points on this. So we know the vertex is going to be -3, -12.5. So I'm going to go over here to -3, -12.5, and put a point right there. That's going to be my vertex. I know that the y-intercept is going to be at -8. I know I'm going to have a 2 and a -8 as x-intercepts. And then the other points that we are aware of right now are -10, 12, and 4, 12. So let's get those on there. -10, 12, and 4, 12. And then you can just kind of do your best to sketch that graph. You could, of course, figure out that that point is also going to be on there, just symmetry. They're really, anytime they ask for something like this, though, what the IB is looking for is like, have you marked these important points that we've all identified? So crummy graph, much nicer graph. It's not perfect, but it's kind of close. Oh, and I wanted 2 units, whatever, so scale this down by half, it's fine. Let t be the tangent at x equals -3. So now we're looking at where x is -3, right there. It wants the tangent line, so when x equals -3, because that's my vertex, I know that that is going to have a slope of 0. So it's just a vertical line, or sorry, horizontal line. I know what lines are, it's fine. Horizontal line at -12.5. And then given that f of a is 5.5 and f prime of a is -6, state whether the function is increasing or decreasing at x equals a. Okay, well, it says that the function is 5.5 at that point, so we'd be looking, so anywhere around 5.5 is like right here. So we're looking at either that point or that point. And it's saying that the derivative is -6. So this one, clearly, if I drew a tangent line, it would have a positive slope. And this one right here would have a negative slope. So it's, because obviously it's decreasing, and also since -6 is a negative, it is decreasing. So you just say it's decreasing, and your reason is that the slope is negative by the derivative. So it's decreasing. Hopefully that wasn't too much. I know it's kind of a long problem. The IB really likes that, but it's just picking pieces apart. Let me know if you have questions.